Okay. Means that I have to remove, I think, some code. On the sad note, Argonis told me that the project was too difficult for him, so he left. How do I delete a branch? I have known this in the past, but how does one delete a branch and also on the remote? Which gives us again a clean master with uncommitted changes. Now I want to remove part of this. Maybe I should add what I want to keep. Or no, I think I just edit it. Okay, let's look at profile if there is anything to edit. Yeah, testing stuff, but I can keep this definitely. And then that should be changed. This should be changed. What is this? Passing if we are backtracking might not be needed anymore. Though I'm not 100% sure actually. No, I don't think that's needed anymore. I'm just going to look at all the divs. I want to keep the reset history. So this is not needed, this is not needed, this is not needed. Almost everything is just passing stuff to functions that are, which is not longer needed, I guess. Yeah, okay. Well, I'm going to do this. Git add -p. Just add what I think needs to be added. So I'm not going to add skill update backtracking. So this can be deleted, as in I don't add it. And then, well, skill update backtracking does not exist anymore. So I'm not adding this. Not passing false there. We want this. Not passing these. Not passing false. That is a correct change. Yeah, that's well unrelated, and let's keep it. It's a bit vague, so just debug code. That is a bug fix, I think. Split this up. So no, not passing backtracking anywhere anymore. So no, can't print it. Not passing it here. Not pausing it there, not pausing it anywhere, not printing it, not pausing it, not pausing it, not having it, not printing it, not pausing it, not printing it. Oh, we don't have backtracking information here anymore. So kind of pointless. Guess this was moved. This is not clear at all. I just want to skip this whole function, I think, for now. Still the same file. This is going to bite me again, though. I can just say no here, I guess. And then we are around. It's not very clear about which file this is it? Silliness, yeah, of course we are in master. I should delete the handle input events as well. I don't even know what it is doing. Tuh. I want to see examples. What is that? Upward mode, div format, page text, div format, examples. Yeah. Changes between the tips of the topic and the master branches. Same as above, changes occurred on the master branch since when the topic branch was started of it. Nope. Forget about it. So what I want is not to pass backtracking. Which means I can't print it. Which means you can't test this. Means that this is always true. Which means that I can move index down again to where it was, but I don't know where it was. Let's not do this. What the hell happened? Okay, yeah, never mind. Probably somewhere here, maybe. And then this can be removed. Yeah, this must be removed, of course. Yeah, this comment must say be removed. I can move this 2 down and the div is gone. Do that. Is that all? So I completely returned it to its previous state then. Except for that I did uncomment these things. Probably should not do that either then. In a minute, I want to keep these. Maybe not committed yet, but I want to keep it. And then this can be restored, and this, and this. And this. And this, and this. And this, and this, and this. Everything except the test suit. I want to know what the current state is if I execute my test suit. We go that way and then we come here back with 14. Yep. And then I have a fit. I don't think the fit is actually through 4. I think it's through a copy of 4, if you get what I mean. 4 itself is no longer in the history, so I think that... I'm not sure actually. I thought it was only working with pointers to samples. The history is not storing pointers, is it? Well, I'm going to refresh my memory on that in a second. So we just jump here and then the scale is including 15, even though it goes... actually it's not. The scale is correct. So here's the critical point, the extreme, the maximum. And the 15 is yeah, on this side. So it's just always the part of the scale. Now the other side is dubious because the point where the second derivative is 0 is probably somewhere here. And then 4 is on the other side. So I think I should not use this as the scale here. It's just too far away. Then I guess I would get 14 as the scale. I cannot ignore 14, I think, because 14 is like part of the approximation. Should not ignore that one. Already kind of silly to do. But on the other hand, maybe not ignoring it is one thing, but I could just reduce it anyway until I hit this point. So because 4 is part of the approximation, but it is beyond this point where the curvature goes the other way, I could pick that as the W value and then have the right scale to be till there. I think I like that idea. Now here the critical point, the maximum here is here. And then obviously right is the correct scale. And left is again past this point here, where the curvature goes the other way. Second derivative 0 here. And 16 is again part of the approximation, so then maybe left should not go until there, but until here. Till this point. That would be left and that would be right. Same thing here. And here. And here. And here. And then we jump there. Yeah, and this is all nice and dandy, but I should add a new approximation instead of just resetting. Surely there's another point you can use. 16 probably. Just because it's the one that is in the closest to this point. So now it is using 23. Yeah, see, that's why I have to use more than just the tangent here. So it's a ridiculous jump. Even though it immediately recovers, I think it is going to jump here. It doesn't. Okay, whoa. Oh, yes. Oh, we're going the wrong way. Yeah, no, it really derailed. It wants to go to the left, so it ignores this minimum here that we had. I don't think it will ever recover from that. Oh, it's going back here. One is 44, 48, 50, slowly going to the left. Yeah, right. Hmm. Lots of work to do. Okay, so in scale, I'm looking for edges somewhere. So like the relevant samples here are the samples from the approximation. Who's calling skill update? Sure. It doesn't work like that. See, I'm using a pointer to current, which is probably stored in the history here. And relevant samples is exist also pointers, which probably also point to the history. Everything is a pointer. This is a simple copy. Should be simple. So I'm also adding pointers to the local point sample from extremes, local extremes. Look in this line. That would be that point 4. Which was already erased from the history, but we're using a pointer to the sample stored in the local extreme. Now, what do I want to do? There is a problem here. Index into samples. So T vector sample data. What I could do is, if I have a sample that And I can't change the sample, of course. I mean, not just because this is const, but hi, Benzi. We put a plus plus first. It's a pre-increment, which means that the result of that expression itself is the result after increment. And I plus plus is post increment, so the result of that is the value of I before incrementing. So if I is not an integer, but it is a complex thing like an iterator, then the pre-increment is better, because a post-increment requires you to make a copy. You have to make a copy of the iterator, then increment it, and then return the copy if you want to do post-increment. If you do pre-increment, you have the iterator you just incremented and then return the iterator that you just incremented, because that's so pre-increment is cheaper. That's why I try to get used, or I am used. I have gotten myself used to using pre-increment, because yeah, in the case of integer it doesn't matter, but in other cases it does matter. So if you can use pre-increment, you should use pre-increment. There's people who just don't get used to it, so they write, say, for int I 0, I is less than 42, I plus plus, and that's what they get used to. And this results in the exact same assembly code as doing this, because yeah, I is just incremented. The return value isn't even used. But if I now is an iterator, and then this is some container begin, of course, and this container end, and then that won't work anymore, where you can use unequal. Then you better use the pre-increment one, because otherwise you have to make a copy of the iterator, which is slightly slower, of course. And then because they have gotten themselves used to this, it's really a matter of, pattern recognition. This looks then good to them, and this looks weird to them. So that's what you want to avoid, the feeling that this looks weird. And that's why I'm always using pre-increment. If I see post-increment, I'm like, oh, not cheap. Do I really need this? And then maybe I'm triggered that way a little bit too often, but well, that was the long answer, because you said thanks. But I really have to concentrate on my own program. I'm thinking that maybe I can change the W value here. Now, normally it would be a cache value of whatever the W value is of sample. But I suppose I could change it once it is stored in the double-ended vector. That means two things. I should never access sample W from something that comes from samples. And I suppose I wouldn't, because that's why I have that cache. Let me check that. So these things, and simply you reach. Oh, wait a minute, that's not working. That no longer matches this W value if I change it. Okay, so I have possibly, well, no, I have at least 2 samples in the double-ended vector samples, but possibly more than 2. But only 2 of them are being pointed at, namely by index, left edge and right edge. And if I'm going to ignore all samples that are beyond the point where my cubic has a second derivative equal to 0, beyond being from the critical point to that point where the derivative is 0, except when the edge, except when they are the samples that the cubic was fitted through, then and now I'm hesitating again. I'm thinking then I was going to say that there is only at most 1 sample beyond that point. But left and right can be on the same side, unfortunately. And what to do in that case? Doesn't really matter, I guess. Well, actually, maybe I just don't want to have a scale crossing that point. So in that case, I should also ignore it. Actually, should ignore the fact that they are both past that point. It's complex. Left edge. So for example, in this case, I'm just initializing stuff. These are the first 2 samples. These 2 samples, therefore, must be the 2 samples that the cubic was fitted through. And they are stored in relevant samples 0 and 1. Here I'm just picking them such that index, the left index is the one that has the smallest W value. Now they are stored in it, and then I'm also picking them as the edge. So at this point we have 2 samples, left and right. Okay, so let the left edge sample be L and the right edge sample be R. Let C be the critical point. At critical point W. Let how do you call the point? That is the inflection point actually. Don't just call it I. I be the inflection point? The cubic. And the following situations are possible. And then in the normal case, you would have. Well, we have a critical. I'm going to assume we have a critical point. It means like literally the assigned here. So we have a critical point. Then of course we can have the inflection point on the right or the left of that, or on top of it actually, if the critical point could be an inflection point. Yeah. The number of extremes is 0. Then this is false, and we take extremes 0, which could be the inflection point. And then of course you have that inflection point can be on the left, so let's make an ASCII drawing of a cubic. Let's add another one. And this is the inflection point, which I can now not denote. Damn it, I need even more lines. I don't think that matters actually. I think. Yeah. That's a lot of possibilities. Currently I'm doing if L and R are on the same side of CP, critical point, okay, like that, then the value is simply the difference between them. Does that change? Now I have an inflection point. This case should not change, really. This should also not change. And what about this case? This is way more complex than it looks actually, because what I had, or have, I don't know, yeah, before I changed it, I still have it, is basically a distance between the left edge and the critical point, and between the right edge and the critical point. And the scale is then the weighted average of that distance. So this distance and that distance, and then weighted with the distance themselves. So we take this distance squared plus this distance squared divided by then this distance plus this distance, or in other words, the total distance. The result of that is that if L is not measured at all, so L is on top of C, then the value is just C to R. And if they are at the same distance, then the value is still C to R or L to C. But if one of them is non-zero but not equal to that one, then it reduces the scale. Then the scale is no longer the larger one, but it's more of an average. And it's not exact, it's just, you know, hand wavy. But the fun thing is that you apply that on something where L and R are on the same side as C, then you just get the difference between the two. To understand again how we got to that difference. So you got there by adding A and B. Or maybe it's just this, some kind of decision. I'm not sure though. I think I came to this conclusion somehow, and then maybe dropped the whole reasoning and just wrote down this. Yeah, I still think that I just don't want any of these points to drift off from the critical point past the inflection point. I think that's what I want. However, that means that, for example, in this case, the scale would be 0 because now R is beyond the inflection point from the critical point, and so is L. So if we just move them both back to on top of I, then their difference becomes 0. Well, surely that's not the case. And that then would be like, I could kind of give the same argumentation that if L and R are just really close, then really the scale should be just a difference. And if they're both on the same side of the inflection point, then I don't care anymore about I and C. I just take the difference here. But then if you look at this case, if now I would move L to I, because they're not anymore on the same side of I, so I would reduce L to be close to I. That means that if R is by coincidence tiny little bit on the left of I, then I would take this whole distance, you know, like that would be this case. And if r would a tiny little bit on the right of I, then I would move L on top of I and the distance would be almost 0. Which is not very continuous and therefore no. So I have to do some kind of weighing average again here. I think it's kind of the same thing that I did with C then. The weighted average relative to I itself. In this case it would be just a difference, and then in this case it would be the weighted average of the distance to I. Yeah. Now that makes sense, but not quite, because I want, if R is on top of I want it to be not important. So it doesn't matter if it's left or right. And we will just get the distance from L to I. But if R moves away from I, or the distance between L and I is equal to I and R, then I want both to be weighted with the same weight, but added, not averaged. I would just want to have the difference between L and R, I think. So what kind of formula do we need for that? And then in this case, if they are like that, then I guess I just want to have the difference again. Here we want to have the average distance with the weighted average distance. And this is of course exactly the same as everything above, it's just mirrored. Well, actually this is the same. So in this case I is on the other side, but yeah, I already took the difference here, so I might as well do that here. So that should be R minus L. This should be G minus L squared plus R minus C squared divided by R minus L. Is that correct? Because if say R and the distance between these two is equal, so this is equal to that one, then this whole thing is just that distance squared times 2. And this is then R minus C plus C minus L, which is 2 times the distance. And then the 2 drops out. So we just get the distance squared divided by the distance, which is the distance. That looks correct. The distance. And here I don't know yet. I mean, I could just move L on top of I. Kind of a cutoff. Yeah, why not? So then the same as this one, but then L replaced with I. Whoops. And this then is again R minus L. And this one was R minus L. Yeah, this should be again this formula. And then this must be the weighted average around I think. So kind of this one, but then C, replacing C with I. Wait a minute, that must be... How the hell do I have C minus L? Oh, wait a minute, never mind. I minus L, yes, correct. And this is then R minus I. Okay, now let's do this one as well. Why not? I mean, must be basically the same thing. This is of course R minus L, because they are completely on one side. This would be the equivalent of that one, yep. And then this must be the equivalent of L in the middle and R on that one, so this one. Yeah. So that is also still the exact same thing then. Just average around C. And here we have them left and right of CI. That is equivalent to this one here. We replaced L with height. So here we have to replace R with I. So this one. And this then is equivalent again to this one, to averaging them around I, which would be just simply the same formula here. And this one is the same as that one. And then I think I can apply that to all cases. So I could move this into calculate value itself and then apply it also. But when calling calculate value here, where possibly other samples are involved as well. For yet not understandable reasons, but that my intuition is always right. So, well, sometimes, mostly, let's put it that way. It feels right, it feels right. Hello, Astro Girls, where I didn't see the chat. No, I forgot to go to my dad. Shall I still go? Probably. Not sure if it is raining or not. I probably should still go. Damn it. Okay, yeah, I'll continue this evening. Yeah, okay.